Chapter 6, Lesson 4, comparing linear and nonlinear functions. We've already talked about these, whether they're linear equations like our vocab says down here, or in our other standard as well, it says linear equation, or if it says a linear function. Both of them mean the same thing, where linear had a line. So today then, our one vocab is nonlinear, where again the word linear started with a line, so when we add the non in front of it, then it's not a line. So that's the big thing. Today, it does not have a constant rate of change, or it's not a line. Or the other thing I'd like you to write on in there, when you're looking at an equation, it's nonlinear if the variable has an exponent. So if the variable has an exponent like x to the fourth power or t squared, whatever it is, then it's not going to be a linear function, aka it's going to be nonlinear. To be nonlinear, it's not a line. So does the table represent a linear, a line, or a nonlinear function? Explain. Well, let's take a look. Does it have a constant rate of change? Do the x's change evenly each time? Yes, they do. Now, clear your mind, and now we're going down to the y's. It does not have to be the exact same number. They just have to change evenly. Is the rate of change even amongst all the y's? Yes, each one is also changing by 1. So, because it has a constant rate of change, it has a slope, ooh, that's a good word, it is a linear function. So you can write down it's a linear function because it has a constant rate of change. It has a slope. Ooh, we can find slope. Rise over, no, not doing that. Just tell me if it's a line or not a line, linear or not linear. So, down here, let's take a look. Does this represent a linear or non-linear function? Across the top, are the x's all changing the same amount? Yes, they're all changing by 3. Now, when I ask you about the bottom, it doesn't have to be that they're all changing by 3. It can be any number as long as the y's are all changing evenly. However, wait a second, that's plus 3, that's plus 5, that's plus 7. Those guys are not changing evenly. So then b is a non-linear function. Why? Because it does not have a constant rate of change, or it has no constant rate of change. It does not have a slope. That's it. No formulas, no work. So that's from a table. We can look at a graph too. I know it seems silly, but does this graph represent a linear or a nonlinear function? Explain. Well, it's not graphed the best. I know it's supposed to be a parabola. You'll learn about that when we talk about that next year in algebra and algebra 2 and all those things. But for right now, it's supposed to be a curved. So is it a straight line? No. So then this is non-linear. Why? Because it's not a line. Why? Because it doesn't have a constant rate of change. Why? Because it doesn't have a slope. So if it's a straight line, then it's a linear because it has a constant rate of change and it is a line. Visually, that's how you can look at it. Otherwise, again, notice again, linear equation, linear function down here as well. Both of those kind of interchangeably, and the same thing down here where you can see we've got function and linear function as well with both of those. So, does this equation represent a linear function? Justify. All right, take a look at that variable. Does the variable have an exponent? If it does, then it's nonlinear. So if it was x squared, x cubed, x to the 25th, then it's nonlinear. This is a linear function. The x, the input, the independent variable, has a power of 1, has an exponent of 1. We talked about that in a few lessons previously, that this is a linear function because it can be written in the form y equals mx plus b. Ooh, another reason why it's a linear function. Oh, tying all these things together. So if there is an exponent up here, then it's nonlinear because it has an exponent. Account A earns simple interest. We're going to learn about that later on this year. Account B earns compound interest. Graph the data and compare the graphs. So to do that, you can see here, we've got our independent variable, our time. So that's going to go along the bottom. Since I only have to go to 5, I'm going to come down here, and I'm going to use a little bit of space. So I can just go over here. 1, 2. So notice I'm skipping a couple just to make my graph a little nicer, I think. At least I hope. 5. You could keep numbering if you wanted to, but since 5 is as far as we have to get on our t, which if you wanted to put that over here, you could. Or if you wanted to label it down here, labeling our graphs would be great. This is time in years. If you wanted to put that in down there too, you could do that. We'll talk about why it's got to be years later. But from there then, you can see we got to get up from 50 to 80. So I've mentioned it before, we could use this little break and you could skip from 0 up to like 50, but I'll talk about that later, why not to do that. So I'm just going to go right on up. I'm going to go by 5s because I can get up there and it'll help me with the graphs nicely. So I'm going to number every other line like normal to make it a little easier to view. So 5, 10, 15, 20, keep on and going. 50, 55 and 60, 65 and 70. Just keep on a going. Get up here to 80, 90. Nice. So let's graph them. I'm going to use 2 different colors. You don't have to technically do that, but it is helpful for us when we talk about graph A and graph B, or account A and account B. So here we go. 0 and 50 for A. So that's going to be right there. My dot's going to be a little bit big, so I might have to change that. But from there then, off we go. We got 1 and 55, so that's going to put it right there. 2 and 60, 3 and 65, 4 and 70, 5 and 75. Nice. That dot's off a little bit, but it'll be all right. From there then, that was graph A. So again, I'll put that up here as a little marker note for us. Then down here, that's graph B. So here we go. Graphing B, it also starts at 0 and 50, and then hits 1 and 55, but now it's a little bit higher than that. It's 60 and a half, or 60.50. So I'm going to go just a little bit above that. Then it's 66, so again, a little bit more above it. 73, and then it's up here at 80. So kind of notice how if we were to keep going, that one's probably going to kind of have a little, see how it's kind of curving up? Whereas the other one, count A, has kind of that straight line. They appear to all be in a nice straight line. So when it talks about comparing, please remember, when you compare, there are more than one right answer, as long as we're comparing correctly. So from there then, what I would say with comparing them is, since we're talking about linear and nonlinear, you could look at the table and see that graph A, or account A rather, is linear. So that's how I'm going to compare it. Account A is linear. I'm going to use a good word, whereas account B is nonlinear. That is not the only right answer. That's just one of them. You could talk about how count A has a constant rate of change and leave it at that. There's so many different things, and we could discuss that in class, but for the sake of the video, I'm just going to leave it here and remind you that there are more than one answers. That's why if you check your answers in the back of the book, the odds only are in the back, It's going to say sample answer because there isn't just one right answer. So today, again, linear equations, linear functions. We're going to identify linear and nonlinear from graphs and tables, and then we're also going to compare them like we just did on that last example.